Section 9.1, the Cartesian Coordinate System. In this video, we are going to look at how to understand the meaning of an equation in two variables. We're going to graph and order labeled pairs of real numbers as points on a plane. We're going to find ordered pairs of real numbers that satisfy a given equation, and then we're going to locate points that are on a given graph. Let's first of all talk about what we mean by coordinate plane. So a coordinate plane has been divided up into four parts called quadrants. When you have a point, it's ordered as an x and a y value. Your x-axis is going to be your horizontal axis, and your y-axis is your vertical axis. So if I have a point xy, let's say we have the point 2, 3, then that means we would count over 2 for our x-axis and then up 3 and locate our dot at that point. So we would put a dot at the point 2, 3, and we'll go ahead and we'll just label that as point A. When we have a coordinate plane, there's some parts to the coordinate plane that are really important. The point 0, 0 is called the origin. We've got it labeled here. You also have in your four quadrants, they're labeled 1, 2, 3, and 4. And notice that they go counterclockwise. In each quadrant, you can tell the signs of your ordered pairs by looking at where it's located along the x or y axis. In the first quadrant, your x is positive and your y is positive. In the second quadrant, our x numbers would be negative because we'd be going to the left, and our y numbers would be positive because we'd be going up. In our third quadrant, our x's are negative because, again, we're going left, and our y's are negative because then we would be going down to get into the third quadrant. And then in the fourth quadrant, our x's are positive because we're going to travel right first, and our y's are negative because then we would travel to the negative or in a downward direction, and that would make our y values negative. So just by knowing the signs of our points, we could tell what quadrant we're in. So if I look at an example like -4, -2, I know that that has to be in quadrant 3 because both values for x and y are negative. In example 1, we're going to graph a set of ordered pairs. So notice that we have our ordered pairs in parentheses, but then since we are connecting, or not connecting, but we are grouping all these ordered pairs as a set of points, we put them in the braces or the brackets. So let's take our coordinate plane and plot our points. So if we want to graph the point -2, 1, remember that the points are always given as an x and then a y. So we would go -2 on the x and then up 1 on the y and put our dot there, and we'll label that as point A. Point B is at -1, -4, so it's to the left 1, down 4, so it'll be there. Point C is at 0, 2, so we're going to go over 0 on the x and up 2 on the y, so that'll put us there. Point D is at the point 1, 3, so that's over 1, up 3, which is going to put me in the first quadrant, and that'll be point D. And point E is at 2, -3, so over +2, down -3 would put me here, and we'd have point E. Let's look at another set of ordered pairs. So this time we're going to graph A is at -1, 3, so over to the left -1, up 3. We'll label that as A. Point B is at 0, 1, so over 0, up 1. Point C is at 1, -1, over 1, down 1. Point D is at 2, -3, so over 2, down 3. And point E is at 3, -5. So over 3, down 5. And what you should notice there is that our points appear to lie in a line. And that's exactly what happens if I connect those points. I should be able to see that I could make a line go through my 5 points. And so one of the things that we're going to be working on is looking at how to graph things that will give us a line when we're done plotting all of our points. In example 2, we're going to determine which, if any, of the ordered pairs that are given here satisfies the equation y equals 3x minus 2. Well, if it satisfies the equation y equals 3x minus 2, what that means is that if I substitute in the given points for x and y, then I'm going to make this equation true. So let's use the point 0, negative 2, and we'll let x be 0, y be negative 2. So that gives me negative 2 equals 3 times 0 minus 2. But then that's going to be, 3 times 0 would be 0. 0 minus 2 is negative 2. And so we do get negative 2 equals negative 2. So that one does satisfy the equation. We'll sort of put a check mark there. How about the ordered pair 2/3 and 0? So again, we're letting 2/3 be x and letting y be 0. So 0 equals 3 times 2/3 minus 2. But 3 times 2/3, that's 2. And 2 minus 2 equals 0. And so yes, those are both equal to 0. So that makes the equation true. And then the point 2,5. If we let x be 2 and y be 5, I get 5 equals 3 times 2 minus 2. But that would be 6 minus 2, which is 4, and 5 does not equal 4. And so the point 2,4 does not, or the ordered pair 2,4 does not satisfy that equation. Now we're going to do something similar to what we just looked at, but now what we're going to do is we're going to find the missing ordered pair, or the missing coordinate that would go with each ordered pair. So in the first ordered pair, I have the x value of 0, and what I want to know is what would the y value be. So if I put 0 in for x, 2 times 0 would be 0, plus 3y would just be 3y equals 12, and then I would divide by 3 and get that y equals 4. So the ordered pairs, or the point 0, would have a y coordinate of 4. Now let's try x is 3. So I want 2 times 3 plus 3y to equal 12. Well, that'd be 6 plus 3y equals 12. Now, solving our equation like we did back in chapter 8, we'll subtract 6 and divide by 3, and we get that y is 2. So when x is 3, y is 2. Now, on the next point, we know the y value. So we're going to solve our equation with a y value of 0. So if we take 2x plus 3 times 0 and set it equal to 12, we get 2x. 3 times 0 is 0. So 2x plus 0 equals 12, or just 2x equals 12. And we'll divide by 2, and x is 6. So when my y coordinate is 0, my x coordinate is 6. And the last one, what if our y is negative 2? So 2x plus 3 times negative 2 equals 12. 3 times negative 2 would be negative 6. But then we're going to add 6 to both sides and get 2x equals 18 and divide by 2 and get that x equals 9. So when our y coordinate is negative 2, our x coordinate is 9. Now we're actually doing the same problems, or very similar to the problems we just completed, but we're going to look at it in table form. So what we have here is, here's our equation, y equals 1 minus 2x, and we have some values for x and a value for y, and they want me to compute the missing value and then write that as an ordered pair. So what if we have x is 0? Well, we would get y equals 1 minus 2 times 0, but that would be 1 minus 0, which is 1. So we could write that here. I just don't have room to fill that in there, so I just did mine at the bottom. You may want to fill it in the block. We now know that y is 1, and so my ordered pair is 0, 1. Now, what if we have that our y value is 3? So I have 3 equals 1 minus 2x. Well, we'll subtract 1. 2 equals negative 2x. Divide by negative 2 and get negative 1 equals x. So our x value is negative 1. So that gives me the ordered pair negative 1, 3. And then the last thing, what if we have that our x value is 5? So I'd have y equals 1 minus 2 times 5. That'd be 1 minus 10, but 1 minus 10 would be negative 9. So our y value is negative 9, and our ordered pair is 5, negative 9. In our last example, we have two different lines that are given here. Each line is going to contain an infinite number of points. We have some that are marked, and what they want me to do is to use the grid lines and locate 3 points that are on each line. So let's look at this first graph, and I'm just going to highlight the points that we're going to use. So let's use this point that hits the y-axis. Let's use this point in quadrant 1 and this point in quadrant 3. And now let's write our ordered pairs. Remember, we list them as an x and then a y. So for our first point, looking in quadrant 3, so we'll just go from left to right, our x value is negative 2 and our y value is negative 1. So that's this point. The next point that touches the y-axis is the point 0, 1. That's our second point. And then we also have this point that is located at 3, 4. So there are 3 points. Now notice there are other points that are on that line, some that are marked, like here, but then you also have a point here that you could have used. So we just had to pick any 3 points on the line. Now let's go to our second line and do the same thing. I'm going to pick this point on the y-axis, then we'll pick this point in quadrant 1, and let's pick this point in quadrant 4. So our ordered pairs, the first point is at 0, 3, because it's over 0 up 3. Our second point is at 1, 1 over 1 up 1. And our third point is at 2, negative 1.